Can you get all of these cups facing down, where each time you turn the cups, you have to turn 2 at the same time? So let's try, for example, rotating these 2. So these 2 are now facing down, but this one's still up. Uh-oh, I'm back where I'm started. So can you solve this problem? Well, in fact, it turns out this task is impossible, and I'm going to explain why. An invariant property is something that's true regardless of what action we take. And the invariant for the cups problem is that the parity of the cups down always remains the same. What I mean by parity is oddness or evenness. In other words, if the number of cups down starts off even, it remains even. And if the number of cups down starts off odd, it remains odd. How do we know this is true? Well, let's consider each of the possible actions we can take. If we have 2 cups which were up and we turn them so they're now both down, what's happened to the number of cups down? Well, it's increased by 2. If they were both down and we turn them so they're now both up, then the number of cups down has decreased by 2. If we had 1 cup up and 1 cup down and turned them, then that has no change to the number of cups down. So if the number of cups down was even, say, then adding 2 or subtracting 2 is going to keep it even. And if the number of cups down was odd, then adding 2 or subtracting 2 is going to keep it odd. Now, when we start, all the cups are up and the number of cups down is 0. But in order for all the cups to be down, we'd have 3 cups down, which is odd. But because the number of cups that start down is even, and we said the parity never changes, so the number of cups down has to remain even, it's not possible for the number of cups down to be odd. And therefore, this task is impossible.